You're welcome to the class. Our topic today is Newton's laws of motion. Sometimes you say it's linear momentum. But in this topic, we're still going to talk about momentum, and so this is Newton's laws of motion. Basically, it's all about motion. For that class, we talked about motion as the change of position of a body. But we also considered some in our previous classes that when you study motion of a body without considering the force that causes the motion, that kind of study is called kinematics. But when you study motion and also consider the force which causes the motion, that study is called dynamics. So dynamics is the study of motion and the force which causes the motion. Force is an agent that causes motion. Force causes bodies to accelerate, causes them to change position, causes them to move from one point to another. Now, we'll consider the first parameter in this discussion. Let's talk about something we call inertia. Inertia is a tendency of a body to remain in a state of rest or be in continual motion. Sometimes you see bodies, if you have a big bag of stone, you tie it, you keep it on the ground in your compound, and you live for 2 years. If nobody remove that stone, that bag of stone, or try to move it from his position, if you come back after 2 years, you still make that bag of stone in that same place. If nothing happens to the bag, or maybe insects or whatever is eating up the bag or something, but the stone will still remain where it is. The reason is because of, as far as the stone is there, it has a force that is keeping it there. It's called the force of inertia. Every object possesses force of inertia. If you are standing as a person, you have force of inertia. That force is keeping you, it causes you to stay at that position of rest, or causes you, if for example you are moving, it causes you to continue to move. So inertia is the tendency or ability of a body to remain in a state of rest, or if possible be in a continual motion. Bodies generally, when they are moving, they want to continue to move and will not stop, except something decide to stop them. Bodies too will want to remain, your pot will remain at that position, you keep it in your kitchen, except somebody come to remove it, or there is an external force that comes around to pull it or push it or remove it from that position. So that is inertia. So when you ask what's inertia, you say it's the tendency or ability of a body to remain in a state of rest or be in continual motion. Now, before we're done with that, we now want to talk about the first law of motion, Newton's first law. So we just say first law. This first law is also called the law of inertia. You can call it law of inertia, you can call it Newton's first law of motion. Now, Isaac was not wrong. Isaac Newton was not wrong. Oh. Isaac Newton said a body will remain in a state of rest or be in continual motion unless the body is acted upon by an external force. So because of that, it's called, just like the law of inertia, they always call it. So what are the consequences of this law? The consequences of this law is something that you are used to in your everyday activity. For example, you are inside a car. You're sitting and maybe you're driving, or you are sitting inside a car. You're not the driver, but you are inside a car. You observe that as the car is moving with a uniform velocity, the car is moving, you'll be in a state, your body will be in a state of continual motion. It will just be moving in a continual motion. But immediately the driver applies that brake, you observe that your body will move a little bit, jerked forward. The reason is because that continual motion, your body wants to remain in that continual motion. That's your inertia. The inertia in you wants to remain in that continual motion. But by the time that external force is applied, that inertia tries to resist it tries to resist the external force. That is why you experience that jerk, forward jerk, which is an uncomfortable, you are uncomfortable at that situation. If you are inside a bus, a loaded bus, like bus where there are some people sitting, standing, and some of you know the name of that bus. If you have that kind of situation, you observe that if there is an external force, which is the brake, immediately the driver applies the brake, you see some people colliding with other people. The reason is because as that bus is moving, it's continual motion. But immediately you apply the brake, the inertia tries to resist that force. Hence, that jerk occurs and people start colliding with themselves. Even it gets to a situation, if the car is moving at a very high speed and that applied force comes in, you observe that people even collide with the chairs, hit each other's head and some other thing. And when accidents occur, this is the reason why there's a lot of injuries. People hit their chest on steerings, on dashboard. So because of that, there is this thing you build with cars called airbag, so as to manage that impact. So that is why when you are using a car, they tell you always make sure you use a seat belt. The reason why you use a seat belt is because of the effect of the first law of motion, that the body will remain in a state of rest or be in continual motion unless acted upon by an external force. Now, that's the first law. I believe you understand that. Now, let's see the second law. But before we talk about the second law, it will be better for us to discuss something we call momentum. Momentum. You say this momentum is something that is practical in your everyday activity. If, for example, these people that, some people in, I think it's in Japan, in Asia, they call them yokozuna, big, heavy looking people. And you have maybe a person of my size. If I collide with a yokozuna, who do you think will move who backward? Is it the yokozuna or me? The question is, the yokozuna may be moving with maybe a very low velocity, and I may be moving with a very high velocity. Maybe my velocity is higher and his own is lower. But because his mass is more than mine, he will still move me backward when we collide. When a small car moving very fast collide with a bus which is bigger, the bus will move the car backward, even when the bus is moving slower than the car. As fast as Ferrari cars are, if they collide with a slow moving lorry, they will be the one to move backward, not the lorry going back. The reason is because of, even the head collision is going to be, it's more serious on the smaller car than the big ones, even with a low velocity. Now, this is the reason. The reason is because of that big car, the heavy lorries, have something called a large momentum. And the smaller cars have small momentum. I colliding with a Yokozuna, I have a smaller momentum when to compare with the Yokozuna man who is having a massive momentum. So, momentum is mass times velocity, which is, momentum is mv. So if, for example, a person A has mass 2 kg, velocity 100 meter per second, and person B has mass 200 kg, person B or body B, then you have velocity of 20, probably 15 meter per second. Probably, let's see, it's a little bit high. Let's say 20 meter per second. Okay, good. Now, what will be the momentum of A? Momentum of A will be mass times velocity. This will be what? 200 kg per meter seconds. Why that of B? Momentum of B will be this, that will be 4,000 kg meter seconds minus 1. So this is 200 kg meter seconds minus 1, and this is 4,000 kg meter seconds. So this body B has a bigger mass. Even when it's moving slow, it's going to have a higher momentum. So if the two of them collide, this B is going to move A backward, surely, because it has a greater momentum. So remember, class, momentum is mass times velocity. It's the product of mass and velocity. Good. Now, let's move on to the next, which is the second law. Second law, which is Newton's second law. Now, it of this form, the law states that the rate of change of momentum of a body is directly proportional to the applied force. Now listen, students, if some words say, or somehow the statement comes as the rate of, anytime you hear the word the rate of, if I say the rate of mass is mass over time, rate is time, the rate of change of that is that thing divided by time. The rate of movement of this is the movement of this divided by time. So always take note of the fact that the rate means time. So the rate of change of momentum of a body is directly proportional to the applied force. So let's put that down. It states that the rate of change of momentum of a body is directly proportional to the applied force moved in the direction of the force. That's the second law of motion. Now, that's that. Now, surely, if you are pulling a body, you have a big trolley. You want to pull the trolley. If you are pulling the trolley, surely the trolley will come towards the direction at which you are pulling it. So the body will move towards the direction of the force pulling it. It will not move in the reverse. So the rate of change of the momentum, change in momentum is mv minus nu. The v stands for final velocity. The u stands for initial velocity. Now, the rate of change of the momentum is mv minus mu divided by t. So the law says that this rate of change is directly proportional to the applied force. That is, F, which is the force, is directly proportional to mv minus mu divided by t, moved in the direction of the force. Now, if that's the case, let's continue with this deduction. We observe that F, this is the law itself. Now F is proportional to m into bracket v minus u divided by t. But we remember that v minus u, in our knowledge of rectilinear motion, that v minus u is equals to a. So therefore, F is proportional to m a. But within the limits of experimental errors, F is equals to kma, and k is equals to 1. So therefore, F is equals to ma. One of the most important formula in physical deduction. F is equals to ma. What is the meaning of m? Mass. A is acceleration. So when I ask you, what's the value of F? You said that F is mass times acceleration of a body. So because of that, then I can rewrite this equation as F is equal to m v minus mu divided by t. So I have two equations now. So we'll have that. Good. Now, let's talk about something else. Or, before that, you've learned this, F is ma. You've learned that change in momentum is mv minus mu. And you've also learned that F is mv minus mu divided by t. And you've learned that the second law of motion states that the force is directly proportional to the rate of change of momentum moved in the direction of the force. Now, let's talk about something that you experience a lot, but you don't know that you experience that thing. It is called impulse of a force. Impulse of a force. The impulse of a force is different. We experience impulse of a force in the toilet. Sometimes you want to get that thing out of your cloaca. As it's coming out, there's this thing that comes out with it, even when you want to fart. You experience a shock. Comes out. There's this shock. Especially when you want to fart. When it comes out, your body experiences a little vibration, some kind of vibration. It depends on the quantity of that is coming out of your... So by the time you experience that shock is due to time effect of force. The time effect of force is called impulse of a force, and that impulse of a force will cause a change in momentum, and it is that change in momentum that causes that vibration that you experience. MV minus MU, initial and final. So from there we can say that impulse of a force is the time effect of a force. It is defined as Ft, force times time, which is equals to mv minus mu. It is Ft minus Ft, and it's also mv minus mu. So you can say impulse is force times time, and impulse is also change in momentum. It is measured in the unit Newton seconds. Newton seconds. Newton seconds. Newton seconds. Okay, that's that. Now we've talked about this, and it will be good when I discuss something else. And the next thing we're going to talk about is called difference between mass and weight.